Okay, cool. Hi, everyone. My name's Ash. I'm a Google developer expert for Android in Berlin. And I'm going to be talking today about using Compose in multi-platform environments. The idea of this talk kind of started from the concept of using Compose in places you probably shouldn't use it. So I wanted to put Compose into a Google Cloud function. Why would I do that? Because I'm insane. But I learned a lot of things along the way, and this is sort of my experience and the kind of fun parts about using Compose in parts of your application that are not necessarily responsible for the UI itself, more about architecture and presentation logic, for example. So if you're not already familiar with Compose, it's a wonderful UI framework, or Compose UI is a wonderful UI framework. It is recommended modern toolkit for UI development on Android. It's been around for a few years now, and for example, it might look like this. And it introduces this concept of declarative UI. So like it models your state much better rather than having to have this kind of hooks and listeners for click listeners or things like this that you might experience from the old days of days gone by. And it's a result of years of collaboration with Google and JetBrains, and the results required a kind of overhaul of the Kotlin compiler to actually allow for this, so have like Kotlin plugins. But what prompted this? And there was this long and colorful history that as Android developers we must be familiar with of using XML for our layout code. And it's technically declarative, but it requires a lot of mutable configuration, click listeners, and for example, and this was kind of cumbersome and difficult to work with. It did have the benefit, however, of years of optimization. So XML layouts were actually performance acceptable. But it also introduces this concept of the lifecycle management, because you'll have to be inflating layouts, you'll be having to kind of register your listeners, actually creating text views and things. So this became a very fun thing for us to work around, as you probably had the mispleasure of working with it before. But it's not the first time that we've had some sort of tool to try and make our lives a bit easier with this. Obviously, the open source community is really strong in this aspect. So the idea of a more granular UI sort of kind of came to fruition. A while ago, there was the Mortar and Flow libraries from Square. Flow handled the navigation with backstack management, and Mortar was more of like a component UI builder thing. There was also that evolved into Workflow from Square. It's very comprehensive, very opinionated, open source and production ready. I believe the Square folks are using it quite extensively, but it's not very heavily documented, and it might not fit your use cases. I would recommend checking it out, but don't feel compelled to use it. There's also the Uber Ribs approach. They kind of adopted the Viper style architectural type. They're both using UDP, unidirectional data flow, and this sort of declarative syntax. Additionally, we had some tooling as well from the open source community and from Google as well, serving this more approachable way of creating your views. So nobody likes having to write this XML stuff. We want to be able to have a syntactic, nice way of creating our views. But since layout inflation is still very Java-esque, it was still kind of a bit cumbersome. But, Kotlin has kind of spoiled us. Now we've had this wonderful thing in our life, we don't want to go back to XML or anything that is Java-esque. This guy's Cotty, named after Kotlin. Yeah, I'm a cat person. So back onto Jetpack Compose UI. Google already announced first-class support for Kotlin in 2017, and 2018 GitHub marked it as the fastest-growing language, and then Google later announced it in 2019 as the preferred approach for Android development. So it is about time for a new UI framework that adopts Kotlin and uses these nice language features that we could then use for our views to replace this XML stuff. So that's when Jetpack Compose was introduced into a preview release in 2019, and the version 1 finally hit production ready in 2021. So, a declarative UI framework focuses more on the what rather than the how. So you might remember these old days where you have all these kind of registration logic and configuration of your UI, where you're setting listeners and setting text values and setting colors and all these different things on your UI, and it requires this sort of like configuration phase in your code, which is not very nice to work with. So Compose kind of readjusts this as a layout as a stateful declaration. It's the antithesis of an imperative usage, and it's a better representation of your state in the UI. Whereas previously you might have to set a click listener, you can just then create your Compose code as it would be. And this then can intelligently recompose your code so that it only redraws the parts that are necessary for the display to the user. And additionally to this, it allows us to kind of employ essential Kotlin features, things like default parameters, higher order functions, trailing lambdas, scopes and receivers, and delegated properties, and more. These niceties, these idioms, as they're referred to in Kotlin, are just features of the language that make it a bit more joyful to use and a bit more kind of user-friendly, and it makes it easy to read, understand, and these things have massive benefits when it comes to joining a new code base, for example. I'm not going to go too much in depth about how it works under the hood. There are lots of great talks about this, but essentially it's just a gap buffer that builds a sort of node structure. Uses a flat array to store group objects, and it sort of can be represented in a visual way like so, but you don't need to worry about it too much. You can just sort of think of it as a UI tree of nodes. But Compose is much, much more than this. So Compose, this is a great quote from our Lord and Savior, Jake Warden. Compose is at its core the general purpose tool. It just for managing a tree of nodes. It doesn't necessarily require you to then use this as in a UI context. You can use it in context other than this when you have a structure like a node to work with. A good parallel to compare this to would be coroutines. So we have a coroutine scope, for example, and this introduces this hierarchical execution, which we can then make use of in Compose as well. And there was a nice kind of paradigm there that I kind of observed about this, which then led me down this rabbit hole of using Compose in places where you might not want to, or might not think about doing it. But essentially, it's important to remember, Compose is not the same as Compose UI. Compose is the runtime. Compose UI is the UI toolkit. Perhaps could be better named. And combine this with Kotlin Multiplatform. So Kotlin Multiplatform is, let's say, a relatively new kid on the block, stable release from 2023, 1.9.2 of Kotlin. But multi-platform itself isn't a new concept. It's been tried many, many different times before. There are lots of different multi-platform frameworks that allow you to target multiple platforms, each demonstrating advantages and disadvantages, some with limited success and some with even less success, and some integrating with the underlying OS and sometimes not. But what was unique, or what was critical about these different approaches is that each framework sort of mandated its own approach, its own language to use, its own IDE in some cases. And whilst each of these ecosystems were not exactly sparse, there was a development community there, these languages and frameworks are not particularly familiar to you if you're coming from an Android or mobile perspective, unless life has been particularly cruel to you. The nice thing about KMP is that it allows you to start small. You can build it in a way that works for your team, for you, for your projects. You can just start and use it in the places that it makes sense, and don't use it in the places that don't make sense. So because you have complete control over this, you can already kind of build it in a small way, in a controlled way that you can then dip your toe, as it were, to try to play around with these frameworks. And there's a lot of strong community backing as well from both Google and JetBrains, and it's a language that is familiar, or should be familiar, to Android developers. And then we introduced a layer on top of this, Compose Multiplatform, which builds upon Kotlin Multiplatform, which became ready for development ready for production in 2021. And it has since kind of recategorized stability declarations, but you don't need to worry too much about this. And when I was looking into how the JetBrains team actually managed this behind the scenes, I imagined some really clever repackaging of Android X releases, or taking the jar files and then doing something fancy with it. But actually, they've just forked the repository and they're manually adapting it. Now, this has become easier and easier as the Android X team have been writing multi-platform code as a standard in the last few years, which has been a great thing for us all. But it requires a constant, huge amount of effort from the JetBrains team, so I was really impressed with that. So if you are interested in working with multi-platform and maybe you only have an Android project, well, great news. You've waited long enough that you don't really have to do much. So you just change your artifact coordinates, do nothing, profit. Of course, in reality, it's a little bit more complicated. There are some gotchas and edge cases here and there, and if you are, for some reason, targeting WASM, then you're going to have a headache. But it will work. Yeah, so this is introducing Compose Multiplatform. Now, I mentioned as well about this using Compose in Google Cloud Functions, and I talked about this in Berlin about hype-driven development, and it's basically solutions looking for a problem, or Maslow's hammer. Or if you're, actually, I wonder if I have a UK audience, if you know the law of the instrument, or the Birmingham screwdriver, as it's commonly known. That joke never lands, and it didn't land here either. But basically, it's playing with tech in new and inventive ways that maybe the author didn't think about, that leads you to new perspectives and new kind of ways about using these things. 9 times out of 10, it probably doesn't work for your problem, but you'll have a fresh perspective and a fresh idea of what you can do. And in that one case out of 10, maybe you've actually found a nice solution. And I mentioned there was similarities here between how Compose is built, or how it is compiled, and how Coroutines works, and how Coroutines was like a massive paradigm shift to the way that we handle asynchronous code. So basically under the hood, Compose compiler plugin is injecting this composer, and it's starting and closing groups of nodes as we're building this UI structure. So considering this from an architectural point of view, it's, like I said, very similar to how we wanted to do with coroutines. Much like layouts in the past, we've had a long and terrible history with asynchronous operations. You might remember async task, because that was a thing. We're confusing a lot of UI logic, front-end logic, domain behavior, and there were lots of edge cases and pitfalls and foot guns and all these kind of different things that were problematic about this. So as a community, we sort of like, okay, we need to find a solution for this, and we found RxJava. And this sort of resulted in using RxJava for everything. For the simple operation of just threading on the background to perform some like I/O operation, be it disk operation or fetching something from the network, we were overutilizing this RxJava, and it introduced a lot of cognitive load. Much like Maslow's hammer, we're using it everywhere. And this complex sample here does like a very simple action, just like prints hey. So why should I have to understand all the things that go on under the hood about RxJava mapping operators and how the sequence of operations is crucial to how your execution is going to happen? I don't need to know this type of things, and it's going to be really difficult for a new developer to learn these things or joining the project, or if they don't have intimate RxJava knowledge. The thing about coroutines is that it has lightweight memory usage. A single thread can support many different coroutines. You have this structured concurrency scopes that manage resources and make sure that things are closed in a timely manner when everything is finished executing. And you have this cancellation propagation. So you're going to have an actual well-built hierarchy of your concurrent operations. And importantly as well is that it's lifecycle aware. So you would have this lifecycle scope that was provided through the Android X libraries to manage your scope and make sure that when the user navigates away from your screen, your coroutines are going to be closed and everything's going to be finished off, or at least it should. In practice, things are a bit weird. But the nice thing about it is that it's a native library. It had this imperative syntax that allowed us to have easier to understand code instead of having all these kind of asynchronous callbacks and this callback hell that you might have experienced in the JavaScript world, and just cool keywords. So suspend fun, it's great. So thinking again about our architectural goals, what do we want to actually achieve in our structure? So thinking about the same thing from the UI and all the things that Compose brings us. So we have this kind of push architecture rather than not pulling. So we have this kind of observation of state, unidirectional data flow. I keep on saying UDP, which is not the same thing. It's declarative and idempotent. Very hard to say. Idempotency is basically the concept of having a pure function. It will always execute the same or produce the same output given the same input. It's predictable, reliable, and it's not going to have some unpredictable nature to your system. Imagine if you've got like a function that takes a mutable argument as a parameter, for example, and then it kind of changes that thing outside of the scope of that function. We don't want to have that because it introduces unpredictability to our system. So as I said, we used to have callbacks, and in some cases we still do. And this is the idea that you have code that executes after an operation. We still have this in a lot of places, but you can quickly end up in callback hell, all this kind of increasing amounts of indentation, which makes it a bit harder to read. I mean, it's aesthetic, it's visual, but if something feels uncomfortable, it's usually because it's wrong. So we evolved this into like an observable chain where everything is a stream and everything is observable. And as I mentioned with RxJava, this quickly became unmanageable with different RxJava operators and mapping functions and things like this. So then we introduced coroutines, and this turns it into more of an imperative syntax. It's a bit chopped off there, but you can see it also chopped off there. But the idea is that you've got this complexity that is reduced down to a single kind of line of operation where we're assigning the value of an asynchronous operation to a parameter here, and it's much, much easier to read. But of course, because we're never satisfied, we then took this logic and made it into a reactive flow because everything should be observable, everything should be flowable or observable or subscribable or consumable, whatever. And we sort of end up with the same sort of structure here where we've got this kind of observation happening. And it's a bit nicely because you have this kind of sealed class state where you can have like loading states or various other representations of like error states or whatever you're kind of trying to achieve in the application. But we still have this kind of same problem where we're having concurrency operations in this kind of weird kind of chain of things going on, and maybe some mapping functions going on in there as well. And we find ourselves back where we were with RxJava. So remembering again where Compose is just a tree of nodes, we can kind of restructure our architecture a little bit and then employ this to our advantage. So now we've got something a little bit harder to read. But we've got the assignment operations here. So like you're fetching something as a downloaded file, and you have the ability to then have like sealed classes or intermediary states, where you can then have this as your kind of current state. And because Compose will recompose the parts that it needs to render your UI logic, this will then invalidate the rest of the dependencies on this variable as and when it's changed. So it allows you to kind of intelligently recompose these things as you need. And it, uses these idiomatic patterns from Compose, reducing cognitive load. And then I stumbled across Molecule, finding out that I wasn't the first to discover Compose in a place that wasn't UI. This had already been done a couple of times by people much smarter than I am. But Molecule is a really nice way of using Compose runtime to build your state. You can take this example here, where we're simply just kind of creating a count and having this launched effect to then every second increase that count. And then this kind of intelligently recomposes as it needs to and allows you to use Compose in a way that you're kind of maybe creating your state. In your view model, for example, or in your presenter or whatever you're using for an architectural pattern, you're actually then having a nice Compose that results in a state flow. Nice thing about state flow is that you can use it with Turbine to test the result of your state operations. So this results in a really nice kind of test syntax where you're producing a state from a composable, and then you're asserting it in your unit tests, assuming you're using unit tests, which you should be. It's also just a great library on its own, so I recommend checking out Turbine if you haven't already. Yeah, just another example. But then moving on to architecture. So we know these things are kind of feasible. We can use Compose in a way that's not stuck to our UI. We can then think about, okay, well, how can I adjust my architecture to have this as an example? We can exploit this. And it's worth noting how interconnected architecture and navigation is. A lot of this is kind of touched on navigation because, well, navigation is a very essential part of every application we have, going from one screen to the next. It is seemingly simple, but actually much more complicated because you have to think about different user interactions, different user interfaces, different screen densities or screen sizes. If you can show more than one screen on the time, think about list detail in your most commonly Gmail or email client. where you might only show one screen on small devices and two screens on larger ones. So navigation is such an essential part of our architecture that we have to take this into consideration. Also should note that Jetpack Navigation 3 is now a thing. This is the evolution of from Navigation 2. And Google heard back from the concerns that this was too opinionated or it was too restrictive in some of the components. And the third iteration allows a bit more kind of flexibility to your own architectural types if you have them. I haven't played with it myself, but it does look promising from what I've seen. So taking frameworks and applying them to Compose, it works fine because Compose is built in a backwards compatible fashion and in terms of language structure anyway. But it seems a little bit unidiomatic. The libraries you might be using might be designed for XML or Android or whatever, but they're not taking advantage of Compose idiomatic features. So it's nice to consider tooling and architectural types and libraries that actually was considered with Compose in mind because it exploits these features and these parts of the language to your benefit. And that's basically kind of what we need to do as engineers. That's our job as a software engineer, is to know and understand the landscape around us and the tooling that's available to us and choose the best tool for the job and how to kind of utilize these tools appropriately. So there's Decompose and Asynchronous, which has been around for some time. And it was a goal to have these kind of lifecycle-aware components in a multi-platform way. So provide an abstraction of these view model and lifecycle interfaces that you might be familiar with, and kind of abstracts those over to other platforms and provide support for the same features that we've come to expect. But these are still very kind of similar to the existing view model, lifecycle layouts, or lifecycle architectural types that we're very familiar with. That probably came from the Java and XML world. So the core principle is the same. You have this component context. Many functions here should be familiar to you, like I said, about lifecycle and instance state handling. You have this observability with value for storage for persistence. So this is how you would manage it on a multi-platform, targeting other platforms, for example. There's also the Voyager framework. I haven't used this myself, but it is... I do have a small sample here, actually. It's a bit of a more simpler approach, and the navigator is provided with the composition. Local keys are keyed against screen class, and are simply just added or removed from the backstack, and you can just build your UI like that. Nice part about this is that the screens are not parsable, so you can just use Kotlin serialization. Some libraries require you to use parcellization, which is okay for Android, but maybe not that pleasant for other platforms. I've also got the API-X, I'm not sure that's pronounced correctly, but it's one from Bumble, and they focus a little bit more about gesture navigation and kind of a bit more animations there, so that's quite nice to work with. And we have the pre-compose, which is basically the same API as Jetpack navigation, but with some tweaks for multi-platform support. I already briefly covered Molecule, and I'd like to kind of go on to mentioning Circuit. Circuit is developed by the folks at Slack, predominantly Zach Sweers, and it takes it takes inspiration from existing approaches, like having the Cash App Broadway workflow, for example, and it's designed with Compose in mind. And the principal tenet of this is that it's a separation of presentation and UI behavior. UDF all the way, no mutability. Screens are keyed against the screen interface as well, and this concept about the UDF concept revolves around your state. It does need to be parsable, so you need to use a parcellized annotation. The screen type is extending from parsable as well, so you need to be aware of that. But that's how Android can manage your backstack in a way that's working on Android. The presenters are quite nicely separated from the UI. So the UI is, so your presenter is actually only responsible for creating your state. And as I mentioned with Molecule, where you can use Compose in this nice little way that is not actually related to UI structure, you're actually just building your state, and you can observe and subscribe to state changes as your needs are met. And then you basically have a basic UI to receive and render this provided state. And because we're good citizens, we add a modifier as well. But it means that this UI behavior is completely separated from your domain logic or where you're creating the state, and you can simply worry about how this is rendered. And then you, of course, will need to wire these things up together. There's some clever annotation code generation from annotations on circuits that works really well with Metro as well, but it's compatible with other DI frameworks. that does all of this stuff for you. But if you're just using it, without annotation or without KPT, you can just kind of manage it like so. Interestingly, the recommended approach for this as well is, recommended approach for this with navigation is handled through the actual state as well. So the idea of UDF is that you have like, your data only flowing in one direction, but you still have events and things coming from your UI, click events or user interactions for various things that need to be communicated to whatever is producing your state. And the state is always gonna have this requirement. So it made sense to have this event sync in part of your state. So then you create your event classes. This is nothing contracted. You just have to extend the event class, but it works well as a sealed interface. And then when you're navigating, you simply just go to this screen on your navigator. I recommend checking out the talk from Zach and Kieran from Conf a few years ago. They go much deeper into depth about this, and it's just a library that I really enjoy using. And it works, like I said, well with Metro, which is the successor to Anvil. That was only like a month or two ago. Designed to be very familiar to you if you work with Dagger or Kotlin Inject. It's very same similar JSR notations, RIP Anvil. So I want to review basic tools here and basic libraries that we can use to use Compose in a non-UI environment. But ultimately, why do you want to do this in the first place? Like, is it just a problem looking for a solution, or just because I want to have fun with a tool, of whatever reason? It's just beneficial to know the drawbacks and the pros and cons for having for each of these different tools, so you know best where to apply it, and know where it might make sense not to apply it. That's also an important decision we have to make as engineers. This idea of write once, run everywhere on Android, desktop, iOS, it's actually kind of working quite well now with Compose Multiplatform. You can avoid duplication of presentation logic and all the multi-platform arguments that you're probably familiar with, and obviously then you don't have to use React. It's also really kind of nice to build prototypes. So if you want to kind of prototype a UI really quickly, it becomes a nice way of doing this for desktop. So you can have your Android application, but maybe you want to have like a small or example UI for just prototyping some ideas. And you can use Compose Multiplatform to then deploy to desktop, where you can get like very quick iterative feedback on what you're doing. And even better now that we can use Compose Hot Reload, which has not quite yet made it into upstream, but it is in progress, I believe. And this gives us near instantaneous UI feedback. It allows us to get like close down this feedback loop that we have. So you no longer have to build your entire system and deploy it to an Android device. You can just play about the UI on desktop. And as we know from Compose, this intelligent recomposition behavior skips execution where it's not necessary. If the input parameters are the same, then we can improve performance upon that. There's a lot of other edge cases and things with strong skipping and stability management. Basically, I recommend using the immutable library from Kotlin X collections. This is because the lists or the map or the collections that you might be familiar with in Kotlin are actually backed by Java implementations on Android, and the implementation on Android is actually mutable under the hood. So it might just be using an array list for a list. So whilst your interface contract is technically immutable, the implementation itself actually is not. So if you're using this immutable library, then you can actually rely upon actual immutability. You can also use a stability configuration file for Compose, or just mark it as immutable or stable. But it is important to remember that these last three don't actually make your code immutable. It's just you saying to the compiler, look, I got this. You do need to actually make sure it's still stable. And this idea of remember. So you might be familiar with remember in Compose using like remember mutable state, for example, so that you can retain the value of a state through recompositions. Using keys as an input, you can then decide how often or under what circumstances should this be retained. So it gives us much more fine-grained control. But it does require a bit of forethought. It doesn't work out of the box. You have to think about what you're doing. So when the value of path changes here, for example, then it's going to have to re-execute this download file. And that's what we're doing. We're passing path as a key to remember to say when path changes. So On Android, we can use remember savable. This is to make sure that it's retained through configuration change. Wonderful experience with lifecycle management. But it must be passable on Android so that it can be serialized and put into the fragment page, which is a bit cumbersome and a bit a pain in the ass. Which is why there's this remember retain from circuit. Now, there's also the remember in Compose now, which is not quite yet available, but it does have this ability to remember something with a scoped management. Haven't used it myself, but I much like this circuit retained. And this doesn't need to implement passable or doesn't have to be serializable. It will just be retained in memory, and it will be persisted through configuration change. And this was really nicely thought out as well through this remember retain coroutine scope operation. You might have applications where you need to perform a long-running application in the background, and there's lots of recommendations for using various tools for managing background operations. TLDR, you probably want to be using Work Manager, but sometimes you might have a requirement to use coroutine scope to have a background operation that's only going to be happening for a short time, but you still want to have it continuing through orientation change. So there's this retained coroutine scope that Chris Baines introduced that you can use to persist coroutine scope through configuration change and thereby allow your asynchronous operations to then also persist through configuration change. Like I said, don't dismiss Work Manager. Maybe it's a little bit more work to kind of implement it, but it's probably going to be the more reliable solution if you have larger things going on. But for simpler things, it's quite appropriate just to use this. And having this as a multi-platform approach means that these concepts of UDF become much, much more powerful because they're applied consistently across different platforms. You've got this idioms as well that are consistent with Compose, this hoisting of state, so your application or your functions are only doing like the minimal amount of work that they actually need, or not taking too many dependencies, not doing all this kind of weird stuff, and you're employing unidirectional data flow as well. You have this shared reactive state handling, so you can be sure, this is just a multi-platform argument. Sorry, this is just an argument for multi-platform in general, but it's really nice when you can use it with Compose. You can also maintain this consistent typography and spacing and theming across all your platforms. Maybe this is actually not what you want. Sometimes you might want your platform to look different if you are unfortunate enough to have to target iOS. But you have this option as well, available as well, where you can use the Cupertino theme to have iOS-themed widgets and UI components and use it in a way that is compatible with both Android and iOS. So this is already available for us. The tooling is there, and we can use it to our advantage. And as well, when Kotlin was first introduced, there was the often argument like it doesn't make sense to use another language if the IDE that you're using was built in this language. Like, it doesn't make sense. So having this IDE first environment that JetBrains put so much effort into building, and you have Compose for desktop, and this tooling is kind of first class. So the JetBrains tools are tightly integrated, and you can have these live previews, and navigation can be supported as well. So you can sort of take these tools and start rethinking how you architecture your application, not just how you're rendering UI behavior. Compose is more than just a UI toolkit. It's also a runtime. You can have your scalable shared architecture producing state separation from presentation and UI. Kotlin first developers, because we all love Kotlin. And multi-platform is not just about business logic, but you can also use it for your UI components as well. And that's all from me. These two guys, Kotti and Pai Pai. Very cute. Thanks.